Um, this is, let's say, stream number 1. As always, I encourage you to like my videos on YouTube. Okay, it's only by doing a like on the videos is what makes them spread, what makes YouTube spread them more. So please like them. Also, if you are here listening to me and you like the videos, please also press that subscribe button on YouTube and also the follow button on the stream. I am trying to get to 500 and I am a bit far away to get to 500. So I would love to reach 500 by the end of this month, but so please click the follow button for this channel. I will appreciate for your merits under each video, okay, in YouTube, because some people do not think or do not click there. First of all, there are the chapters, okay, so you can see what you are maybe interested in. If you are interested in a small piece of the whole video, and there are links related to code or to playlists, so please check what's under the video. Of course, may I remind you that I have a Facebook page where I post everything that I do, basically, or what I'm going to do, and which is also the Phase 101 page. Then there is the Phase 101 Facebook group, okay, and you can tell the difference because it has got this logo, that the image is there to indicate to me which group it is, to be honest. But if anyone can guess, I haven't said this to anyone, but there's a sentence written here where there is zeros and one. If anyone can guess what's written there, please let me know. Also, there is the Facebook group Commodore Dev. So please join the group if you like. What is it's completely dedicated to Commodore 8-bit 16 machines, so anything will be there in relation to it, as you can see from what I'm showing. If you want to get in touch with me, the best way is to come to my Discord. I do see, if you post me messages on Facebook, I do see them, okay, but it takes me time. Discord, I'm constantly It's easy, it's constantly there. So I'm constantly checking it. So please join there. If you also would like to join Telegram, I have a Phase 101 Telegram group if you want to be there. There are 23 members. It's only new this, so I haven't been using it I haven't done it for quite a long time, but if you prefer that, you can join there. If you like what we do, then please, and would like to support us, then you have two options. Either on Patreon, okay, which will unlock 63 videos. It's because I released one today, it was 64. Or Coffee, which they both has the same content, okay? So there isn't a difference between one and the other. May I remind you also that there is the page the page related to, if you type exclamation mark book page, you get the link to this page. It is with links related to Amiga programming, okay? So, oh, some more people commented, I didn't realize. I update this maybe once a month, not a lot, once or twice, but every time I see something that is helpful for beginners or to make your coding experience easier, I do not add all the links. It has to be specific to Amiga coding. Okay. Hello, Betcat. Thanks for being here. I didn't see a follow, so I'm not sure if you're following the stream or not, but you asked me, is it possible to change? This is an English stream today, okay? So I hope you can understand English. To change the color of the piranha in the game Popeye. You should be able to do that. Yes. Hello, Amok. Nice to see you here, and thanks for the subscription. Wow. Thank you, Amok. 30 months. Wow. I do not know what to say, but thank you. Yes, Batcat, I'm going to reply to you in Italian. Sì, lo puoi cambiare usando quel programma che ho mostrato ieri. Non so se stavi seguendo il mio... Hello, Coder. Sì, si può cambiare, però devi salvare il gioco dopo, altrimenti cambia il colore di nuovo. Sì, sì, sì. Continuo in inglese adesso, ok? Hello, Oscar Coder. So, guys, please follow my master, okay? Oscar Coder. He does cool programming related to Commodore 64 or actually all 8-bit of Commodore. There isn't a machine that he doesn't code for, basically. from the Commodore range, and he's also adding like BBC and things like that. So please follow him, check his YouTube channel. There's lots of videos there. He has double of what I have, I think, or something like that, for the 6502, while I am more concentrated on the Amiga side, so 68,000. But please follow him. He's also participating in the Game Jam, and for those of you that might have missed his stream, I ask you to check it because his game is really cool. I hope he doesn't make it difficult for me because I need to show it, and you know how good I am in playing games. Yeah, Nico will run forever or crash forever. Depends how difficult it is. Anyway, so let's jump to Visual Code. We have our guest, Ozzy. Okay, let me open the microphone for Ozzy.
Hello.
Hello, Ozzy. Hello. I guess all his kids wants to see him.
Yeah. As always, I told you before, my family is a lot invasive and quite noisy. So I must wait for my daughters to go to sleep to do the live. But anyway, I will try.
Yeah, it's okay. So let me change the code. So during this, let's say, while I was on holiday, I guess, and after I came, Ozzy was preparing these. I mean, I'm not sure if it was when I was on holiday or the last week when you prepared them, but I'm assuming while I was on holiday. So we are going to start doing a series about coding, Amiga intro or demo coding, using the framework of Ozzy, which I do not have a link to it. Is it on? It's not in the comments neither. So if you can you type a link to your GitHub.
The framework, the libraries are on my GitHub.
Yeah.
The examples that I gave you are not uploaded anywhere.
Yeah.
You're the only owner, I think.
Okay.
But if you want, I can upload
No, but
it
what
somewhere.
I wanted to do is share your GitHub so that others can see what you do. I mean, I understand that this code is only I'm the only one having it so far. It's mine.
Yeah.
But yeah, back to basics, Dockster. Yes. But I wanted to share the link of your. To be honest, I think. Okay. I'm going to share something. So, guys, Ozzy wrote this tool, okay, which I use also, okay, for the Amiga. It's online. His Amiga font editor, okay, but it's not just a font editor. It started with fonts, okay, but then it became sprite position, register conversion, couple list translator for the screens, this display window start and stop, point projection, okay, trigonomic tables, which I haven't used this part, and raw to planar. and RGB planners, RGB colors. Okay, so if, like me, you suffer in converting graphics to RAW, etc., there is another tool that you can use that was written by His Majesty Ozzy. Okay, so that's his work.
Yeah, the RGB page, I think it's quite new. I wrote last week, I think.
Uh-huh. There you go. And
It's just
I was going to ask you, was it there? Because I noticed that I
no,
didn't know
no.
about it.
It's recent, and what it does, it helps you to calculate the transition from one RGB color to another in Amiga format. So 4 bits for green, for blue, and
Yeah,
4 bits for red. This
yeah.
is what it does.
Yeah, because colors in on the Amiga are 4 bits wide, so from 0 to 15, not from 0 to 5, like on PC. So they are not 8 bits, but 4 bits.
Yeah, 4 bits for each color.
So I'm going to run his first lesson, let's call it like that, to show you what it does. Hopefully it will work. No, it will work. I tested it, I did everything, I converted everything yesterday, so I know it will work. So I'm going to assemble it so that it's proof, okay? And now this is where what I haven't done. I should have started the Amiga, which I haven't started. So let me start my own Amiga. Still booting. So what we are going to do is we're going to show you code. Okay, actually we're going to show you what the code does. Then we'll show you the code, and Ozzy will explain it. Maybe not to the detail that you might be expecting, because we have he will go in detail further down the series. Let's put it this way. So that assembled. Okay, here is the Amiga. I'm just going to move this in the lower right hand corner. So and going to run it now. Okay, and all it does so far, you see a dot on the screen, a pixel on the screen, because that's from where you start. Okay, it's as I said, this is from the beginning.
The very beginning.
Yeah, so Dockster, yeah, you're laughing, but are you able to plot a pixel onto the screen using plot? So that's the first thing you need. You need a plot. And no, you see? So the code that we have here does that. So I need to give you live share, no?
Yeah, let me open Visual Studio. Let me see if I remember how to do live share.
I need to activate it.
Okay, live share, and I needed the link.
Yeah. I'm going to send it to you on Discord. Direct message to you.
Direct message. Why Discord is so hard to learn.
There you go.
Okay, I got it. So let's try this live share. Paste. I should be in. Please confirm.
It should have displayed me a message. Yeah, let me see.
Yeah.
Okay. Well,
Yeah,
hold on a
I
second.
think.
Hold on a second. Following you, I need to give you control. Okay, you have control of the session.
Okay. Can I move the cursor?
Yes, you should be able to. Yeah, I can see it moving.
Okay. So just let me start explaining something, because of course a dot, a plotted dot, it's not something very groundbreaking for this channel, but this is important for me because it's where I started my journey, and this is a point plotted. If you notice, the file name is in Italian. This is why. This is because I literally copied code from the book, the RapJam book, and this is the very same script that you can find inside the lessons of the book. And what I did, I just wrote my own version of the plotted dot starting from here. And so you should be already familiar with this code. I'm sorry if the comments are in Italian, but as you probably know, the book is in Italian language, so I didn't have the time to translate. And also I wrote these 8 examples in one evening, so not when you were on vacation, but it was just I was in a rush, and this is why the intention is so bad, and also the comments are so bad. So, but essentially what this little program does, it just sets a bit plane. It sets a copper list, have you already seen thousands of times. And the interesting part is just these 4 lines. And if you notice, there is a jump to a point routine, which is essentially the same routine from RamJam, but it was enhanced by me with my customization. But the fundamentals are still the same. This routine just references the correct byte, then it tries to calculate which bit must be turned on, and that's it. Before the point, the jump into point label, I set D0 data register and D1 data register. And this is where the routine is expecting the values in x and y coordinates where to plot. And width and height are just some defines, some definitions. Somewhere in my libraries there is width is 320 and height is 256, and this is what I usually work on a PAL low-res resolution. And of course, if you divide by 2, you go to the center of the screen. So my point is you are moving from the top left of the screen down half of the screen and right half of the screen, and you end up in the exact center. And then there you plot the point. Nothing very interesting. And the stroke, it's just a macro that lets you select the color. So in this case, you are plotting with color number 2, and the colors are defined inside the copper list. And if I remembering correctly, the first color 1 is red, the second color is green, and the third color is blue. And color 0 is black, and not very fancy, but it should be quite easy to understand and to remember. And that's it. That's all for this first code section. I think it's very quick, just a plot point, and probably you should have, if you are following Prince Phase 1.1, you should know this routine by heart.
Yeah, they should.
Yeah, they should, because this is one of the very first examples in the book, and everybody should have read this.
Yeah. If you permit me, okay, I'm just going to highlight a few things just to show what you did in relation to what I've been saying that they should do, okay? So he is following the book like I do, and notice, to be compatible, he's also switching off AGA. You know, there is always these things. The startup file is there, okay? The DMA is there. This is a standard way of doing things, so that when you start coding or when you are doing your things, you find it easier if you follow this structure, let's say, for coding for the Amiga. I do have one question to Ozzy. Why you are using JSR and not BSR here?
JSR and not B. It depends, because
The section is different.
yeah, and there is, I think, quite big distance. Anyway, the problem is that I'm not using a linker so far, and this is something that has to do with my build routines. So right now, okay, you are right. I should avoid to use just the jumps, but for now they are required, because I'm missing the whole build structure, and it could be anywhere. It could be in a different section, and it could be in a very distant section, in a very distant line, memory location from where it's called.
Yeah. But no, yes, the reason why I ask it is why I asked is to show that probably you have different sections. So basically, they are not in the same segment, and that was more my point, more than why you really used it, because probably your code is scattered in different sections, so, and because of that you have to use JSR.
Yeah, for now, yes, but this is something that I'm planning to address in the future when I have time.
Yeah, okay.
And some sort of optimization, because right now, if you notice, I have a bunch of include files on the top, and this is the problem. I'm not linking my function. They are just included in the same...
Sure, I understand, yeah.
Okay, this is the problem. But anyway, we will return to this maybe in the next meetings.
Yeah. And notice the copy list is also very small, just setting up the screen, okay, the bit plane, and then the color. Nothing out of this world. So his framework is this, basically. which is also available. This part is available on GitHub, no?
Yes,
Yeah.
this part is all in my AProcessing folder on
Yeah.
GitHub.
Okay, so let's jump to the second example.
Just to point out something, the copper list is pretty much the same in all the examples, so there's no need to go over and over all. So open the second file, yes. I think that live share
yes, every time I'm going, because every time is going to drop between one project and another, because that we change project now. So, but anyway, in the meantime, I need to show it on the Amiga now, so it's okay.
Yeah.
So let's assemble it. Okay, so I'm going to run it. And we have another dot. Magic! Oh my god, we have another dot.
Yeah, different for color, maybe, I don't remember.
No, there's something that he will need to explain. Anyway, we have another dot. Okay?
Yeah.
So let's me move the out of the Amiga again. Okay, and I need to give you again live share.
I think that the audience will be very amazed from these awesome demonstrations.
It's what needs to be known. So again, I'm going to give you the
link.
Yes.
Got it? Copied. Live share. Join. Paste. Come on. I should be in.
Yeah, you are in. And you have control.
Okay.
Sorry. You have control now.
Start?
You have control now.
Okay. So probably you have already noticed that the output is identical, but this is another way to plot a point, or in general to draw. And the difference now is this. So indentation is broken, but doesn't matter. Now we are plotting to 0, 0. So the x position is 0 and the y position is 0. And so you are probably asking
Point
yourself, how is it possible? You just asked for the top left point, and is it still centered? And should be maybe it's a bug. It's not a bug. It behaves in this way because we have a routine before, which is translate, and this is not something new. Probably if you studied OpenGL, this is a pretty common and well-known function, and the concept is, whenever you call a translate, you are changing the plane, the references of the plane. You are changing, in this case, you are telling the Amiga that coordinate 0 x and 0 y is no more on the top left of the screen, but is on the center. And notice again, I put the width divided by 2 into d0, which is the x position, and the height divided by 2, which is on d1 register, and it corresponds to the y position. And these two registers are then read from the translate routine, and the translate routine internally has a thing that is called a transformation matrix. And the transformation matrix is, if you remember from the university, you have this strange subject called algebra, linear algebra, and they taught how to perform matrix calculation. You can add matrix, you can multiply matrix. There are two types of multiplication. You can subtract matrix, and there are different matrix, but I don't want to go into this today because it's a pretty far complicated stuff. I just want to tell you that the translate routine, you can find it in OpenGL and other popular libraries, frameworks. It's very common on computer graphics. So I didn't invent it. I just tried to re-implement on the Amiga the very same concept. So what I'm doing right now, I'm just telling the Amiga, please, the center of the coordinate system is the center of the screen, the same. And then, of course, we plot relative to the at coordinate 0, 0, relative to the center of the screen, we still see a dot on the center of the screen. And so the output is different. It's a little bit more complicated because, as you see, there are two routines involved, so it takes a little bit of time to compute the new position. But we have some benefits that we will discover later, maybe if I have time. But that's it. It's the very same situation as before, very same outputs, and the copper list is the same, and the colors are the same, the init routine is the same, even the file name is the same. So nothing really changes. We are always in that dot position, let's say. And remember that, okay, we'll talk about this later, but this is just like a state machine. It means that the translate will be always the same throughout the entire cycle. So if you plot another point, it will be relative to the center of the screen in this case, because the transformation matrix is stored somewhere in the RAM, and it's always read. So my point routine, as you may guess, is all the same of RamJam, but it calculates coordinates according to a transformation matrix, which is not shown here. It's inside one of the include files on the top. But I'm repeating, I don't want to go there right now. I just want to show the overview of the project.
Yeah. So all these things, I mean, I was discussing this with Ozzy before we actually started this stream. He will go into more depth, and probably he will explain all this. But for now, we are just showing you the principles behind it, what you need to know to be able to achieve certain things. And then he will explain how those things were done. So
yeah,
we go to number 3. Is it
yes,
okay?
please proceed.
So one. There we go, and we'll bring the Amiga. So now we have 2 dots. Okay, I hope you can see it. I mean, it's quite small, but yeah, there is a one green, one red. Okay, so more magic.
Yeah, even more interesting.
Yeah, but who will explain the theory behind it? Why? So I need to give you again
Yeah, the screen
live share.
share link. Okay, got it. Copy it. Live share. I'm in once
Yeah,
again.
just give me a second to give you control because it hasn't shown up yet here. Now you have control.
Good. So once again, same exact init routine, same exact include files, copper list pointing, BPL pointers pointing, DMA, and so on. And now what's different? It's this. This is the relevant part. So the point routine is called twice. First time is called as before at coordinate 0, 0. And of course, since the translate routine has been called before, we have been moving the center of the coordinate system to the center of the screen. But as you can see, there is this leggy joist routine, and this is another piece of code that I stole or copied from RunGem. And what it does, it just reads the joystick movements up, down, left, right, and it increases the counters. There are two counters. The first one is relative to the X counter and the other to the Y counter. So when you, for example, you press left on your joystick, there is a variable which is sprite X, which is a word, and it's increased or decreased. If you press right, it's increased, otherwise it's decreased. The same stuff for the up down, which affects the sprite Y location. So what I want to demonstrate with this is if you move the joystick, I don't know if you have control
Well,
of the
I didn't
joystick.
do it intentionally. Here it is. Okay, I didn't do it intentionally. So basically, I'm moving the joystick and it's drawing lines, basically, the way by reading the joystick. So, yeah.
Yeah, and this is a little digression. There is a game, and it's called Quicks. Back in the days, I don't know if you remember this game. It was very fun because you move a cursor across the screen, and when you close a polygon, there is a piece of an image that pops out in the background. And usually it was about naked women or something like that. And some times ago, I tried to make my own Quicks version, and I used this technique to draw to the screen. So, but this is a little digression. What I want to demonstrate here is that translate once again moves the center of the word according to the joystick. Then you plot 2 points and notice that the 2 points are remembering where the center of the coordinate system is, and this is why the red dot is always 1 pixel to the right and 1 pixel to the bottom, if compared to the first dot position. And
can you repeat that?
So I plotted the 2 points.
Yeah.
The first point is at coordinate 0, 0 relative to where the joystick is. And the second is relative to position 1, 1. Relative to the... So what I'm trying to say is that the translate instruction is affecting all the 2 calls to the point routine, and not just one, because the point routine remembers which is the transformation matrix, and it recalculates the coordinate according to the center of the screen that you gave to translate. This is the whole point. It's a state machine. This is how OpenGL works, and this is how I try to reproduce the behaviors of OpenGL. Of course, this is not even comparable to OpenGL because it's too simple and there are a lot of limitations, but that's how I have fun. But the important thing to notice is that you will get always the same distance between the 2 dots. The red dot will be always 1 point down and 1 point right, because it's relative to the very same center of the screen.
There is a question from Dockster. Will 0, 0 always be in the middle of the screen? It's like a vector then.
We are using vectors to calculate the position of the points. So nothing new about it. I don't understand the question. Will 0, 0 will be in the middle of the screen? The answer is, in this particular example, no, because the center of the screen is relative of the joystick movement. So if you move the joystick to the right, the center of the center of the screen of the coordinate system will be to the right. If you move, for example, this example starts with the center of the coordinates at the center of the screen as before. But if you move for 1 frame the joystick to the right, the center of the screen will be at X position 161 and Y position 128. If you move again to the right, at the next frame, the center of the coordinate system will be at 162 for the X position and the same for the Y position. I don't know if I got it the idea.
No, I understood you, but yeah, this is quite interesting. And it was a good question, Dockster, because even I was thinking that the center was still was always 0 at 0, 0 in the center of the screen. So yeah, good question.
The point of the translate function is please move the center of the word across the screen. This is the main purpose, because when you, if you recall the first example, I plotted the point at position 160, 128, but it was relative to the 0, 0 position, which is the top left of the screen. Now the pivot point, so the reference is no more the upper left corner because I move it with the translate routine. And this is why I end up to the center of the screen. From there, according to the movement of the joystick, I change again each frame where is the center of where is the intersection of the X and Y axis. So the origin of the Cartesian. So this is the whole idea. And later we will see why it's so useful to think in terms of relative position rather than absolute position according to 0.0 on the top left of the screen. And just a reminder for everyone, the Y position is inverted in computer graphics. When we go to school, they teach us that if you increase Y, you go up. And on the Amiga and in general in computer graphics, it's exactly the opposite. It doesn't work like a school. So 0, a Y.0 means top of the screen, and Y equals 255 means the last raster line of the screen. But I'm very sure that all your audience already knows this stuff.
I didn't. I'm being honest. To be honest, I think I knew it, but I forgot it because I didn't use it anymore. So, well,
okay, I will say we can proceed with the following example.
Yeah. Oh, we have something better now. We have something better. So, we have two rectangles on the screen, or two squares.
Squares.
Okay? And I can move them, as you can see. So,
yeah, they are squares, but sometimes they appear right rectangles. This is because probably when we use a PC monitor,
yeah, yes, exactly.
the image is stretched in some way, can be stretched. But since I do all this stuff on my my Commodore monitor, it's model 1084.
Wait. Yeah.
And this is different.
Yeah,
it looks very different.
But my Amiga is proportional, so it should still be looking, as you notice, it's a square. Should still look like it should. That's why I did not make it the whole screen, because else it will become not anymore a square but a rectangle. But yeah. Okay, so same thing.
Yes, I need the link. Got it. Copy. And oops. Copy link. I'm in once again.
Yeah, I need to wait till it tells me. Yeah. Okay, you are in control again.
Okay, as you can see, we are going very slow because all the examples are very similar one to each other. So just to better understand what is going on. So the first thing that you notice here that we have this clear top function, and this is not very important. It just clears the whole bit plane because right now I want the squares to be moving on the screen. If you remember, in the last example, the plot was not erased at each frame, so you have this tray, like it looks like a road. But this time, every frame I delete the whole bit planes, and then I plot over again with my routines. In order to achieve this, I usually do a double buffering technique. And this is why in the make file there is a small change that instruct my routine, please every frame switch the bit plane memory, because otherwise you have this strange flickering on the center of the screen if the routine takes too much time, and we don't want to raise the beam. So other than that, the example is exactly just like before. The difference is that we have always the translate, which is relative to the joystick movement. And then we must, of course, wait the blitter, because we can't write on the same portion of memory when the blitter is operating. And then we start to draw squares other than point. But the concept is exactly the same. Here we are just saying we are putting coordinate -5 into the 0, and the same for register D1, sorry. So the register D0 and D1 holds the coordinate point of the upper left point of the square. This is where the square is started. And into the D5 register, there is the size of the square. So each size of the square, it must be 10 pixels. And that's it. Of course, you might wonder why I picked negative numbers. And the answer is pretty simple, because I wanted the square to be centered exactly on the center of the screen. If I put 0.0 or 0.0, the upper left corner of the square will be on the center of the screen, and the bottom right corner would be at position 10, 10. So you must add, of course, the height, the width divided by 2, and height divided by 2 to this coordinate system. And the square will be slightly decentered towards the bottom left and the right of the screen. So this is why I put the size divided by 2 and put a negative in front of it. Of course, we have the stroke too, with the first square is using color 2, and the second one is using color 1. And this is important. You have, since it's a state machine, every time you want to change color while drawing, you have to define the stroke. And this is similar to what Intuition is doing with. I remember there is a set pen function in the Amiga OS. It's the same concept. So the important part here, again, remember that the second square is always relative to the center. So what the framework, or let's say my functioners, are doing, they calculate the center of the screen, or if you move the joystick, the center of the screen plus the offset of the joystick, and then they go to position 15, 15, and they start plotting the upper left corner of the square from here, and they go down drawing the square. Okay. And this is what it does. I hope it's clear. I think.
Okay. Can I ask you a question? Because I'm trying to imagine it, because for you it's easy to imagine things, but because you've been doing this for quite some time. But for me to get to the crypts to where you are, it will take me some time. So the red square that we see on the screen is always relative to the green square. And the green square is right now the center of the world, if we want to call it, always where the coordinate system starts. It's 0, 0, right?
Yes,
Yeah.
of course.
So if I move the green square at location 0, 0 of the origin of the screen, okay, the center of the world is still 0, 0 there.
The center of the world is where it's not so. Right now, you moved the joystick. You pressed up several times,
Yes.
and you pressed left several times.
Yeah.
Each frame, the coordinate system changed.
Yes.
And it was decreased according to the X and the Y position. So let's say right now you probably are at 10, 10. Let's say.
Yes.
So the center of the world is now at 10, 10. Let's say.
Which is in your coordinate system, it is 0, 0 in that case.
Yes.
Okay.
In that my coordinate system. So the important part that you have to remember is this. Since the green square is plotted -5, it will be always centered according to the new coordinate system that you just updated with the joystick.
While I was moving the green square with the joystick, I was moving the coordinate system where the 0, 0 is.
Exactly.
Okay.
You are not moving the square. You are moving,
yes.
You are changing the word.
Yeah. But just to keep it simple, so maybe the others, because I'm pretty sure I'm not the only one that have difficulties in understanding it in a way, because first of all, I'm older than you. I haven't done this for ages, so for me to grip the grips with it takes me some time. So that's why I asked the question. So again, I'm going to move it up here. Right now, 0, 0 is where the green square is.
Yeah, the center of the green square.
Yeah, the center. Yeah, of course, the center. Okay. Perfect. So wherever we move it, the green square, that's the 0, 0 coordinate.
Okay.
Are you saying that you are moving the camera? Not sure I understand this question from Doxter. He's saying, are you saying you move the camera?
The camera, yes, in a way. It depends how do you see it. If your camera pointing to the 0, 0, yes, you are moving to the camera.
Yeah. Okay.
I will say yes. So, but for me, it's not a good example, because usually you do this type of things with the Amiga, changing the bit plane pointers.
Yes,
okay, because the two squares are moving together, so their distance between the distance between the two squares is always the same. So you don't need to repaint everything over and over again. This is not a PC. This is an Amiga. We are smarter, and we move things changing the bit plane pointers. So for me, the bit plane pointers are the camera. In this case, what we are doing, we are completely erasing the two play fields. And then we are drawing again the squares, but using a different coordinate system. We are just saying that the center of the Cartesian axis is no more the top left corner, but it's somewhere, some position, random position on the screen, which is dictated by the movement of the joystick. And this is the concept. Of course, if you want the the squares to move independently, you have two options with the Amiga. You can put the first into bit plane 0 and the second square into bit plane 1 and poke to the bit plane register, or simply, if you have more stuff and all must be moved independently, you can use this technique. So erase and redraw again, and over.
Okay, Dexter told you he was thinking in Unity terms, but you answered his question and he understood. So
yeah, the problem is that Unity 3D, if this is the commercial product that
yes,
he
yes,
is referring, has this camera concept. And yes, but it's not like an Amiga. An Amiga works quite differently. For me, the camera in the Amiga are the bit plane pointers, because if you increase the bit plane pointers, you see the objects that are shifting position. So this is the camera.
Can we do number 5 now?
Let me check my notes if I forgot something. Throw a point. Sample. This was example number 3, I guess. 4. We are already at 4. We are going like speed of light. Okay, I talk about the double duff. So we are good to go. We can proceed to example number 5 if we have time.
So.
And according to my notes, this is where things are getting a little bit complicated. You should see some rotating stuff.
Yes. Okay. So let's see it. There you go. We have center square, the green one, and the red one going around the green one. That's all I can comment.
And this time I make it, I was smarter because I drew the center of the coordinate system.
Yes.
I plotted the two lines, and the first line represents the x position, the x-axis, sorry, and the second represents the y-axis, and the intersection of these two lines represent where the translate function is going. And as you can see, there is the green square, it's like blinking, and this is because of on my Amiga I have a big problem, and this is the trigonometric function. If you recall from the school, there are these two trigonometric function called sine and cosine, and there are periodic function, and they go from 0 to 1 to -1, and they start over again. And to calculate the sine function, I need real numbers. Unfortunately, the Motorola 68000 only gives me two instructions, which are mulu and mults, and these are only for integer, so I had to figure out something to represent a decimal number without using a mantissa and an exponent, and I came up with this solution that was quite quick, but of course I lose precision. So I will talk about this technique, about fixed point notation maybe in the future, but the calculations are not so precise and not so clean, and this is why the pixel is not really always in the best spot, but whatever. In this example, what I really want to show is why we need to calculate, to move the origin of the axis. And this is why when we rotate, we can't just say to our computer or our Amiga rotate, because Amiga doesn't know about rotation. You have to yield to give the Amiga in additional information. So first of all, you have to specify around which axis I want to rotate. And in this case, I'm rotating around the z-axis, because we are in a 2D world and we don't have a y x-axis to rotate. I wrote the routine also for 3D, so it's possible with my framework, my collection of routines, as I prefer to call them. Is it possible to rotate along the x and y axis again, or maybe all of three together? No problem. It's just a computational problem because there is some math involved and there are some multiplications involved. And as you already know, the Motorola is quite quick at shifting bits, at moving bits, copying. But when it comes to multiplications or worst divisions, it really struggles and takes a lot of cycles. This is why I always say the demo scener is a cheater, because he doesn't use these instructions. He doesn't compute at real time what the vertex of the square in this case. It just pre-calculates somewhere. It stores the pre-calculated values somewhere in RAM, and then it draws according to these pre-calculated values. But right now, we are calculating in real time, and I would say it's quite good because I don't see any stuttering, or I think we are at 50 frames per second. So I'm pretty happy with my result.
I said, yes, you are at 50 frames per second.
Yeah, please consider that the problem with with let's say demonstration is that in order to draw a square, or this is a very little square, but it involves a lot of data movement, because every frame you have to plot a lot of bytes inside the bit plane. And the problem is if the squares are very big, the Amiga will struggle painting it. Right now I'm using the CPU to plot. This is not efficient if you have all the stock A500, for example, or 600s. It can be done on 1200 or accelerated Amigas, but it would be better to do it with the blitter, because the blitter has its own fill routine, so you don't have to compute with the processor the filling algorithm. And another thing that I would like to tell you that the vertex are I draw lines between the vertex, and these are drawn with an algorithm called the Bresenheim algorithm, which is a CPU algorithm. I think it's implemented inside the blitter, but in this version I'm using only the CPU. Again, I have the counterpart square version for the blitter, if you are targeting stock Amigas, so no problem with that. But for this example is using the CPU. And still, if you keep the square quite small, it can go at 50 frames per second. But anyway,
you have a question. You have a question. If will it still rotate correctly if the square is bigger?
oh, you can try it right now. Open the editor and try to increase the square size, and let's see what it does. Even if you don't share the screen, I will just say what to do.
Yeah, okay, so where the squares are is here, no? So
You go where there is the jump to the square routine. And notice that the D5 is 10. So the third move at line 102, you just increase, let's say, 20. So you replaced 10 with 20. And
should
this
I do
is
the
for
other one too? Both of them?
Yes. Yeah, good. And then you go do the same with the second square.
Yeah, I did it.
20, not 12, okay. And then you just save and compile and run it again. And let's see what happens. Maybe it will explode and it will be a meltdown.
Now it will be fine.
I'm always nervous when I code
Really?
live because I fear the guru meditation.
You feel the guru meditation?
Yeah.
You must have seen it as much as I see it. And if you use the blitter, you see it a lot. There you go.
Wait a moment because the live stream is a little bit behind. Okay.
There is a small issue, I think, but it's because you have the lines.
I don't know why it behaves like this. Okay, you changed the upper left point to be centered, but this is why it's happening.
It's still at 50 frames per second, whatever it's doing.
Yeah, please also replace -5 with -10.
Uh-huh.
And it should be correct.
So
this
for
is a
both
live
squares,
experiment.
for both of them, right?
Yes, for both of them.
One was 15 though, not -5.
Okay, so instead of 15, you have to subtract 5, so it becomes 10. Yeah, try this.
And it's still at 50 frames per second.
Yeah, there is a little glitch because they are overlapping and they are on the same bit plane, and this usually should be addressed by plotting to an off bit plane memory and then plot back into the bit planes with the logic operator or of the blitter. But yes, this is how it works. You can also increase again, and it should be fine. You can add another square, for example. You can play and do whatever you want. But the point of the whole the thing is that, as I said before, you can't just say please rotate. You have to specify the axis rotation and the point that you used to as a reference for the rotation. So in this case, we are rotating around the center. And notice the first square is rotating around its own center because the center of the first square is the same of the center of the origin.
Yes.
But the second one is, now it's 1010 because you changed it. And the second square is rotating around the center of the screen. So this is why we need to change the origin, because for rotation, the rotation is computed relative to the center of the screen. If you move, you can also try to put back the joystick routine function to move the center, but
I wanted to ask you something. So if I look at the code, okay, your part, the block of code where it starts, I assume this is drawing the lines. I mean, I know that you have a leg, so I'm just waiting for you. These two are drawing the two lines that you said.
Yeah.
Then you are resetting the transformation matrix.
Yeah, in this case, I don't know if it's necessary. I put it just to be safe, but I think you can restart this reset current transformation matrix. Let's try it. It should be removable.
Yeah, so I can comment it out.
Yeah, try it.
Yeah. Do you mind if I continue going a bit with the code to understand what you've done?
Okay, yes.
Here you have the where the center of origin is. We're using the translate, right?
Yes. So we are going to the center of the screen.
Yeah. Now, here is where I am a bit confused. Here you have the angle and rotate rectangle. Then you have another batch of calculation.
Okay, I can explain.
Yeah.
From line 89 up to line 95, all it does is this. We are calling rotate underscore reg. Reg stands for register because we are passing values with the register. I have another version of the rotate that uses memory, but I wanted to be consistent, and I put this version. So this routine expects the angle of rotation into register D0. Now, usually we do this in radians and not in degrees, but my routine, I prefer thinking relative to degrees because I have the problem of integers. I am having a hard time representing decimal numbers. So let's say we do things simple and we just can do rotation for integer numbers, so natural numbers, from 0 up to 359. So I store the initial rotation variable, which is 0, and rotating by 0 degrees means do not rotate, essentially. Doesn't make sense.
Yeah.
Okay, so at the first frame, you have this angle, which is 0, and you rotate by 0, so you don't rotate. Then you add 1 to the variable angle. And so the next time you will rotate by 1. And the next frame you will rotate by 2, by 3,
I got you.
So on. Yeah. Now, if you reach 360, we have a problem because the sign values are stored inside a list, let's say a table, okay? And if you go further, then you say I want to rotate by 1000 degrees. This is of course it's possible, but I had to compute and do the modules of 360, and this is a waste of resources. So what I did, I just said, okay, if you are at 360, just reset to 0. So the loop starts over again. So this is what this block of code is doing.
And then you are saying the position of where the first square is, right? And then you are waiting for the splitter, and then you plot the square basically.
Yeah,
right?
In this case, we are saying that the square is of size 20. So you have to decrease the upper left point to center the square, and then you wait the blitter because you can't draw while the blitter is raising the previous square, and then of course you do the square drawing. Then you change the color and you do the same stuff again. So it's very, very simple, and all the complexity is hidden, I would say, because you don't see the transformation matrix, you don't see all the math that is involved while drawing.
So because people might think that the plot routine is the most difficult routine. It's not. That is very short, and it is the same one as you heard him, the one that is in the book. It's this function or routine, okay, and probably this routine, and what else? Where it can be quite complex right now. I'm not sure. I'm not sure if this is complex or not.
For me, the most complex part was the filling algorithm without using the blitter. This was the hardest part because you have to optimize a lot. The Motorola is really struggling filling a figure without the blitter. I think that the Amiga without the fill feature of the blitter wouldn't be an Amiga. It would be just like any other 68-based computer.
Definitely.
Because the blitter is so important, it's so crucial for stock Amigas. You can do without.
Gyro Geyser, wow, thank you very much for the raid. Wow, 42. Wow, thank you very much for the raid. So, for those that are new, I am Phase 101. Basically, today we are discussing, and actually it's the first episode of this series, of how to do basically Amiga demos, let's put it this way, but starting from just a simple thing, plotting a dot on the screen, and from there basically we are expanding. That's our aim. I normally stream Amiga stuff except on Tuesday. Tuesday is Commodore 64, and Friday, Saturday, Sunday is Amiga. Saturday and Sunday, Saturday is Italian, Sunday is English, and it is based on a book related to Fabio Ciucci book. And today we are, let's say, expanding, because the routines are part of them in the book, expanding what there is thanks to Ozzy, and thank you very much, Oli, for the follow. Expanding on that and starting to build, let's say, our knowledge, okay, thanks to Ozzy, on making such demos that we love to see on the Amiga when it comes to 3D things or 2D things rotating on the screen. So, yeah. Ozzy?
Yes.
Sorry, I interrupted you. I forgot what you were saying. Because of the raid, I have to interrupt you.
I wasn't saying anything in particular. I just want to say that the same concept applies also to 3D. So you can use the same methods translate, there is a 3D version of translate, and there is a rotate version for 3D. The problem is that the computational power needed to calculate all the vertices is increasing exponentially. So right now I'm just doing some basic 2D stuff for this reason. Maybe next time we can do a cube or something like that, some 3D object, a pyramid, I don't know. But it applies the same concept. You just need to expand the transformation matrix and add some more data to crunch.
Okay. So, shall we pass to number 6 or do we have time?
I think it's safe to go on to the next example.
Thank you very much, Fansweld, for the follow. By the way, I'm trying to reach 500, so if you've just came raiders and you like what we do, please click on that follow button.
I see a question from Doxter.
Sorry, I missed that. Is the stroke?
And the answer is simple. They are macros. I love macros.
He's asking if it's defined. It's a macro. Okay, yeah.
It is. They are both macros, and I use macros extensively because if I just need, I avoid the saving stuff on the stack and calling RTS, so I have a little bit of boost, but there are some downsides. For simple thing, I think macros are excellent. For more complex, I would tend to avoid using that.
Same philosophy.
Okay, we are at, I lost count of
number
the examples.
6. Number 6. Yeah.
Okay.
So this is the example that we had before, and I'm going to go to number 6. Why dot? Stupid DOS. So this is number 6.
Okay, same example, and the concept here is, let's say we don't want the second square to be rotated. This is difficult because when we draw the second square, we already changed the coordinate system with the translate and rotate. So we have applied 2 times 2 different transformation matrix. And so how to solve this problem? We have multiple ways. For example, if we want to do not rotate, we just can invert the rotation. So for example, if the first square is rotated by 45 degrees, we just say rotate minus 45 degrees, and then the transformation matrix is the same as before, and the square doesn't rotate. But there is a better way to do this, because as like every time we call rotate, some computational power is needed, and we don't want to recalculate. So we don't want to add and subtract the same values. And this is where push and pop comes into play. So please open the code, and I will explain just reading the code. I think Doxter has another question.
You can
you
fly
can.
the red square with the joystick. Nah, he's joking now.
Yeah.
Do you want control or I just need to scroll the screen and that's it?
Just scroll the screen.
Yeah.
We don't waste time with live share because it's really the same stuff over and
Okay,
over
okay.
again.
Fair enough.
Okay, so the change here is the push matrix and the pop matrix, and line 89 and line 112. And so what we are saying this here is, please, dear Amiga, first go to the center of the screen with translate. Then let's say put a flag here. So remember this state and store it somewhere. So you can think of push like storing. If you are in information technology, you probably know that there is this strange thing called a stack. So like a stack of dishes. So we are storing, so putting on the top of the stack the current transformation matrix, and then we rotate, so we change the transformation matrix. And then we, of course, we draw the square. Then, after the green square is drawn, we restore popping from the top of the stack, so we are back at the center of the screen without the rotation, and then we just draw the second square. Doing so, we can save some CPU power, and it's for me it's better and more human readable code. So
Yes,
this
good trick.
is the main purpose of the push and pop, just to remember the state of the transformation matrix, store it somewhere, and remember that every time you pop it, you are deleting it. So usually you should push and pop in a couple. You can't push and 3 times pop. So the number of pushes must be equal to the pops. And of course, if you pop again, you go back to the 0, 0 top left coordinate system that was at the beginning. And that's it, I would say. I think it's pretty handy. One thing to mention is that, of course, storing this stack takes memory, RAM, and you can adjust your stack size using a particular directive at compile time. So you can say, please allow max 10 pushes or 20 pushes according to your project, because of course we don't have infinite memory in the Amiga. So there is this trick. Of course, if you don't use push and pop at all, you just say the stack size is 0, and you save quite a lot of RAM. And that's it, I would say.
Okay, so do you have, because if we do number 7, then we have to do number 8. Um,
Why don't we have number 7?
no, I said if we do number 7, we need to do number 8. Because you know what happens in number 7.
Yes.
Yeah?
Yeah.
So do you have time or for
Yeah.
both? Yes?
I will go until the 8th
Okay.
example at
Okay,
this
so then we
point.
continue. No, it's fine. I just ask you because I know what happens now, so
I will try to do quickly my speech and close before midnight.
okay. No, it's fine. You can stay till 2 o'clock if you want. I'm still okay. Okay, so let's do number 7. So I'm bringing back the Amiga.
And prepare for the worst.
Yeah, I know. I know what's going to happen, so. Watch carefully, guys. By the way, hello, Hound Dog. Thanks for coming in, and thanks once again for to Gyro. I cannot say your surname. Sorry, your name exactly. Gyro Geyser, I cannot say it. Sorry, Gyro something. And hello, Dario. Also, Pelicus is the king. Yeah. So let's run it. Look at it properly, guys, because my Amiga is by.
It's okay. It didn't behave like on my setup. I got the crash very quickly. But of course, yeah,
I tell you why, but it crashed. It's crashed.
yeah,
It.
it
I tell
crashed.
you why, because I have more memory.
Yeah, try to decrease memory. In my Amiga, the crash occurred right when the square exited
No, it's crashed.
the playfield.
It just don't show it, but it's crashed. I cannot do anything. Look, it's nothing. I can click
Yeah,
as much as I want. It's
and
Guru
Pellicus got to the point quite very quickly. The problem here is that
clipping.
the
Yeah, I know
yeah,
what.
I didn't introduce clipping, and it will be subject of the next example. But the problem is that if you rotate and the origin of the axis quite far away, like in this example, there is a high chance that the the rotation trajectory will go outside the memory allocated for the bit plane. And if this happens, there are some unexpected behaviors like this. Probably you get a crash, you get a guru meditation or whatever. So this was just to show off that my routines, I calculate the vertex and they draw. No matter where they can't check the boundaries of the memory allocated for the bit plane. They just calculate the byte and they write on it. If inside this byte there is some code or something that is not meant to be deleted or changed or altered in any way, doesn't care. This is the beauty of the Amiga, because if you go outside the memory allocation scope, it crashes. It's not like Linux when we have, and then there is a kernel who gives you a segmentation fault if you are
Yes, it
doing
was meant.
something wrong.
Yes,
So
Dogster, it was meant to crash.
yeah, this is just to introduce the next example, which is clipping. And what I tried to do, it was to avoid these situations, because of course you can increase the size of the bit plane, but still maybe in a game you could need clipping, probably. I don't know. Solving my problem, I need clipping. And what I did is just add a new parameter inside a compilation time. And if you give this new parameter, every time a vertex is calculated, the boundaries are checked against the memory. And if it's detected as outside of the memory location, it's clipped. So the shape of the figure is recalculated according to the boundaries. And this is This is example number 7, right?
Yes. Shall I go 8?
Yeah, just go down, just to explain further, and go to the rotate function inside example number 7. And this is the problem. Stroke 2, wait, later, draw first. Is this number 7? Oh yeah,
Yes. Yes, it is
there
number
is
7.
there is 85. So we are plotting 85. So the upper left corner of the square is 85 pixels to the right to the origin. So the trajectory will be a very loose circle, and it will go outside the bit plane data. And this is the problem. If you put, let's say, 20 like before, no problem, because the trajectory will stay inside. But the problem is that if you rotate, so we translate to the center of the screen, and then we rotate around the center, but the radius of the circle is too much to handle. So we got a crash for this reason. So the fix is quite simple. Please open Makefile for example number 8.
So you
First,
want me to open project number 8, no?
yes, the code and the Makefile.
Yeah.
Just to demonstrate how
That's
I
the
solved
Makefile.
this problem. Yes. So you see here, this is the compilation we are using. There is a -d use clipping. When you do this, you add this, some additional code is compiled or assembled. And this additional code do the following. It takes the line that you are drawing, and it checks the vertex. So it's not a line, it's a segment actually. And if this segment goes, one of the two vertices goes outside the rectangle of the bit plane, it performs, let's say, some sort of equation, a system of equation, to determine where is the intersection point with the last bit of the available in the bit plane. And it recalculates the shape of the figure. And that's it. This should avoid crashes of any size. But the problem is that in order to do this math, I need the divs and div instruction, and they are very slow. So I will tend, if you are working in a stock A500, I would rather try to extend the memory meant for bit planes and readjust the copper list instead of using this solution. I tried this solution on my vampire, and the vampires really it doesn't matter if you are doing a move or a div or whatever instruction. It's always very super fast, and probably also the other processor, let's say 6840 or 6860. I don't know, but what I can tell you, all this makes sense if you have a very strong Amiga with a very powerful CPU. Otherwise, at default, all of these is disabled. And now you can just run the last example just to show how clipping works.
Okay, that's done. So There you go.
Okay, here you can see the two squares are clipped. The outer layer is entirely clipped when it's outside the playfield. And the other, you can see clearly that the shape is recalculated when it touches the border of the screen. So at a certain point, it's a triangle, then it's in a regular polygon. It depends of the situation, but I think it's still 50 frames per
Yes, it is.
second.
It is. It is. It
I
is.
don't know if you are using fast RAM, probably. This
No, no, it's
why.
emulation, but yes, I do have fast RAM, but it is still doing 50 frames per second. I think it's still able to do it at this size. I think. I mean, I don't know.
Yeah, yeah, it's quite good for my shitty code because we have three polygons and they are
And
rotating
the
each frame.
emulation is exact timing, so it's not that I'm trying to cheat by having something faster. It's exact timing. So
Uh, I like what Hound Dog said. It's a solar system simulator. Indeed, if you study OpenGL, at a certain point there is probably everywhere an exercise ask you to say, let's do a solar system simulation just to explain how rotation works. So this is the moon is missing. You should have add an additional rotation and change again the point of reference. Make a sphere rotating around square. Example should be cool, but yes, with this you can
yeah,
you can just do some sort of simulation, astronomic simulation, of course. And this concludes my examples.
yes,
Just one very last thing I want to note to say again. Um, I love Demoscene and I did all of this because of my project, my intro. But as I told you before, the demo scene is a scam. Let's say everyone cheats. So there's no almost it's very difficult to see real-time calculation on Amiga demo scene. And I think a good optimization for this would be to recalculate every transformation metric somewhere and then apply without and the math every time. So I think this stuff will be more suitable for a game. For example, you want to a racing game, let's say a supercar game, the top-down games. You can add some physics here, and you should have like super off-road, something like that. You just place the square with the let's say an image with a PNG file, and you control the rotation with the joystick, and then you have the super off-road game, let's say. Maybe it's a more suitable application. For the machine, it's good, of course. You can pre-calculate all the rotations before the demo starts, of course. You don't need to let's say, use dc.w and title data. It can save some RAM, but yes. The point is that real-time simulation and real-time computation it's not good for demo scene. But still, it's important to understand this concept if you want to do some very basic computer graphics.
Dario is not agreeing 100% with you. He's saying that there are, which I think there are also. I think there are a few that really do calculations, but I also think, like you, Ozzy, there are too many cheaters in the demo scene. It's one of the reasons why I think I do not like the demo scene anymore. While during my time, it was hard to cheat like that. because you need access to a PC to calculate certain things and all that stuff.
I would say that it's true that we have some demos with real-time calculation, but for what I see, the main goal of the demo scene was to impress the viewer. So
yes,
if it can do something pre-calculated to add more stuff, and do some say live cycle saving stuff, he will do it, of course. In a game, you can't do all this pre-calculation because it must be the response must be according what the player is doing. So
yeah,
it's more difficult to cheat. Of course, there are areas when you also can pre-calculate on a game. But however, what is saying Dario is true. There are a lot of demos with real-time 3D graphic calculation, but again, you have to deal with the slow processor and the small limited Amiga resources. So if you want to rotate a cube, okay, it's good. If you want to rotate 100 cubes, it's not
not
possible,
possible.
probably not even with precalculation, but precalculation will help you a lot, of course. But anyway, in these demos and on all this stuff that I'm doing, precalculation is limited to sine and cosines function only, and I don't cheat for now.
Good one.
Okay, he is mentioning tech demos, and these demos are illegal. For me, this is not possible. They are not demos. It's just black magic for me. So I won't comment this. There are some demo sceners, demo group that really are doing something that I think it's impossible on the Amiga. I wouldn't know even how to start to do something like tech.
Anyway, okay, so I think we are finished for today. These were our examples that we had. We had 8 examples. I hope you enjoyed what we have showed you. If you are still here and you haven't yet followed the stream, please click the follow button. We will continue with this next week, right, Ozzy?
Yes.
Yeah. And he will continue to expand on the subject next week. I found it very interesting. I don't know you guys, but for me, this is what Ozzy showed us today is a game changer for myself. I always wanted to, well, to be honest, I knew some of these, but I forgot and I couldn't get the grips of it. And somehow Ozzy is reminding me of things. So I'm very thankful for this. And honestly, it's super. Because it's not just for, if you think about it, it's not just for demos. These things you can also might need them in games. So yeah, it's good to know these, let's say, techniques or this way of handling things. So guys, thank you, and I hope to see you next week. Thank you very much. Bye bye.